Maxwell's equations are four elegant and fundamental equations in electromagnetism. They describe how electric and magnetic fields interact. The first two equations are based on Gauss's law about the production of the electric and magnetic fields. However, the third and fourth laws are based on Stokes' theorem that shows the effects if one of the fields is changed. The first equation describes the electrostatic, the electric field around a point charge. For example, a lone charge such as an electron will produce an electric field. It tells us the total amount of electric field lines passing through a closed surface depends on the electric charge inside the surface. Mathematically speaking, the electric flux through a closed surface is equivalent to the total charge enclosed within that surface. More charge leads to a stronger electric field. In general, there are no magnetic monopoles. Even if we divided the magnets into halves, two magnets would be formed each with the south and north poles. Magnets always form loops of magnetic fields, and they don't have charges. The lines are continuous, meaning the total magnetic flux through a closed surface is zero. The third law states that in a closed circuit, changing the magnetic field induces an electromotive force that generates an induced electric current in it. For example, moving the magnet closer or farther away from a coil can produce an electric current in the wire. This means that the electromotive force induced in a closed circuit is proportional to the rate of change of the magnetic flux. The fourth law states that a change in the electric currents and fields can produce magnetic fields. For example, if we have a wired loop such that a current is flowing through it, there will be a magnetic field circling around the wire. It states that the total magnetic field around a closed path is proportional to the total current enclosed by that path. This was in general the friendly definitions of the four equations of Maxwell's.